Hello, my name is Alex Zerenin, and I am a Senior Solution Architect at AWS. Today we will talk about migrating SQL Server to AWS Cloud. We have an extensive agenda for this session, covering various aspects of migrating SQL Server to AWS. So let's jump in. Why are we discussing migration of SQL Server workloads to the cloud? At this day and age, benefits of the cloud migration, such as agility, elasticity, speed of innovation, cost reduction, and many more, are practically common knowledge. On top of that, AWS offers best-in-class performance for SQL Server workloads, broad range of VM instances, and impressive set of tools supporting the whole process of cloud migration. Partnering with AWS, you as a customer inherit our remarkable rate of innovation. So either it is today or tomorrow, you can be assured that your workloads are running on the advanced and modern platform. However, to realize reliability, performance, elasticity, and cost savings offered by AWS, you have to be on AWS. Successful migration of SQL Server to the AWS cloud is based upon generating detailed inventory of your SQL servers and their dependencies, identifying authentication scheme, capturing your high availability and disaster recovery requirements, assessing your performance targets, and evaluating licensing options. Answering these questions will assist in deciding on target database platform as well as define your migration options. AWS provides broadest and deepest set of tools contributing to successful completion of these prerequisites. Planning migration of SQL Server workloads to AWS could bring us to 6 R's of migration. The retain, retire, and replace or repurchase do not actually include moving SQL Server to the cloud. So in the following discussion, we will focus on learn rehost, replatform, and refactor options. So what are our options to run SQL Server on AWS? If you deploy self-managed SQL Server on AWS EC2, you will have full access to all AWS resources. The new features such as recently announced R5B family with storage throughput up to 260,000 IOPS and new high durability and high performance IO2 class of EBS volumes are immediately available for your use. You also have an option to deploy your databases on locally attached NVMe SSD storage, given that you provide it for its ephemeral nature by configuring high availability solution. Alternatively, you may use Amazon RDS for SQL Server, a fully managed deployment solution with an SLA of 99.95%. As a managed solution, RDS has some limitations in terms of database size and instance selection. Innovation trickled down to RDS at a slower pace, as they need to be certified for the managed solution. However, Amazon RDS is easy to set up, operate, and scale, and it relieves you from all the heavy lifting of configuration and management. These two hosting options closely correspond to rehost and replatform R's of 6 R's of migration. Some of the migration mechanisms that we will look at work equally well for either SQL Server on EC2 or RDS, while others are more attuned to one of those platforms. During the talk, I will emphasize what target platform respective migration solution applicable to. We already identified benefits of the cloud, but to achieve these benefits, we need to first migrate our SQL Server to AWS Cloud. Our focus will be on these 5 options for database migration. We would not consider, for example, scripting the database and data, as from a practicality perspective, it is only applicable for really small databases. Similarly, we would not consider SQL Server mirroring, as it is scheduled for deprecation and not recommended by Microsoft for new projects. One of the most straightforward ways to migrate your SQL Server workloads to AWS is to replicate your on-premises or other cloud-based infrastructure to AWS using our no-cost Cloud Endure migration tool. This tool relies on Cloud Endure agent, which need to be installed on your servers. Once the agent is installed and activated, it begins initial block-level replication. This may take anywhere from several minutes to several days, depending on the amount of data to be replicated and available bandwidths between your on-premises environment and AWS. After the initial replication is complete, the source machines are continuously monitored so that only changes to source machines are replicated into the low-cost staging area on AWS. The replication at this point enters continuous data protection, or CDP state. When the replication reaches the CDP state, you can launch a target infrastructure in test mode. Once you complete all your testing and are ready to fully transition your database to the AWS, you can perform the cutover mode action. Typically, you may achieve a cutover time between 5 to 20 minutes, depending on the data change rate and network latency. Please keep in mind that Cloud Endure can also be used to replicate database environments between AWS regions, thus providing relatively inexpensive DR solution. If your environment consists primarily of virtual machines, you may benefit from another no-cost migration tool offered by AWS, the Server Migration Service, or SMS. AWS SMS supports migration of virtual machines from VMware, Hyper-V, or Microsoft Azure, but it doesn't currently support physical infrastructure. AWS SMS uses the Server Migration Connector, which is a pre-configured FreeBSD virtual machine that you install into your virtualization environment on the hypervisor level before the migration can start. The SMS connector is responsible for taking snapshots, sending them to AWS SMS, and converting them to an Amazon machine image. Using this setup, you can build the migration target environment in minutes, but it will be at least 1 hour behind the source environment due to the SMS snapshot replication schedule. While relatively easy and fast, server rehost approach has some shortcomings resulting from direct replication of the original servers. You cannot change version of underlying OS, version or edition of SQL Server, or replatform to Amazon RDS. Additionally, you are carrying over any configuration that the virtual machines had. So instead of starting afresh, you are starting with whatever configuration you had previously. SQL Server database migration using native backup restore may address these shortcomings. AWS offers a broad set of tools to bring your database backups to AWS, starting with AWS Storage Gateway and AWS Data Sync to move your backups across the wire, followed by Amazon S3 and Amazon FSx to store your database backups on AWS. If your database is too large or would take too long to transfer over the wire, AWS offers a Snow family of products capable of transporting up to exabytes of data into AWS. So let's see, how we can use these tools for migration. AWS Storage Gateway is a hybrid storage appliance that you deploy on your network. Storage Gateway exposes a file share on your network, which you may use as the target for SQL Server backups. To speed up backup operations, Storage Gateway contains configurable local cache. The best practice is to set up this cache large enough to store the whole backup. Cached backups will be seamlessly uploaded over the VPN or Direct Connect to an S3 bucket on AWS. From this bucket, the full, differential, on-transaction log backups can be directly restored to Amazon RDS or downloaded to a file system and then restored to SQL Server on EC2. Thus, you can keep your on-premises and in-the-cloud databases in sync until you are ready to do the cutover to AWS. If the target of your migration is SQL Server on EC2, you may simplify your migration by using AWS Data Sync. AWS Data Sync is deployed in AWS Cloud and relies on the Data Sync agent that should be deployed on-premises. SQL Server backups will be directed to some local share, which will be monitored by AWS Data Sync agent. New or changed files are uploaded to AWS Data Sync and can be stored at Amazon FSx for Windows File Server. From Amazon FSx, backup files can be directly restored to SQL Server on EC2. AWS Data Sync can transfer over the VPN or AWS Direct Connect links hundreds of terabytes at speeds up to 10 times faster than open source tools. It also monitors data transfer, validates transferred data, and optimizes network utilization for file transfer. What if the size of your database backup exceeds the throughput of your VPN or Direct Connect link to AWS, precluding you from uploading your backup to AWS in reasonable amount of time? That's where the AWS Snow family of products come to the rescue. They range in capacity from 8 terabytes to Snowcone to 80 terabytes for Snowball Edge to hundreds of petabytes for Snowmobile. Snow family devices and vehicles are owned and managed by AWS and are delivered to your premises upon request. After the Snow device delivered to your premises and connected to your network, you can configure, manage, and monitor your device using AWS Ops Hub. When configured, Snow device will expose a file share that can be used to back up your SQL Server databases. When the backup is completed, the Snow device is being shipped back to AWS. All data on Snow devices is encrypted, and devices themselves are tamper-proof. Upon delivery to AWS, your backup data will be uploaded to your S3 bucket, allowing you to restore your databases to Amazon RDS or SQL Server on EC2. But what if you cannot suspend operations of your on-premises SQL Server while you are waiting for the Snow device to reach AWS, backups uploaded to S3 bucket, and then restored to the target SQL Server platform? To address this issue, you may implement a hybrid solution with the initial backup transferred over the Snow device and subsequent changes transferred in the form of differential and transaction log backups using some online solution like AWS Data Sync. After the initial backup reached AWS and restored to your target platform, your target SQL Server can catch up by restoring subsequent backups and kept in sync with production database with regular transaction log restore. When you're ready to cut over to AWS, you will need just a short period of downtime to process the last transaction log backup. While the slide presents this solution targeting SQL Server on EC2, it would work equally well for Amazon RDS for SQL Server, with the latter case benefiting from using storage gateway instead of the data sink, as we discussed earlier. Another option to migrate your databases to AWS is to use SQL Server replication. This approach would be especially fitting if you're already using SQL Server replication on premises. Then you may just add additional subscriber on AWS. Transactional replication typically starts with a snapshot of the publication database objects and data. If your database is too large as compared to the throughput of your VPN or Direct Connect link to AWS, the initial snapshot could be applied through a backup delivered to AWS over the Snow devices, as we discussed earlier. As soon as the initial snapshot is taken, subsequent data changes and schema modifications made at the publisher are usually delivered to subscriber in near real time. Both RDS for SQL Server and SQL Server on EC2 could be subscribers to the replication. If you're already using SQL Server Always-On Availability Group on premises, and your connectivity level is sufficient to move your data across, you may extend your on-premises availability group to AWS to transfer data and keep your on-premises and in the cloud databases in sync until the moment you cut over to the cloud. But how would you know if you have enough spare bandwidth to keep your availability group in sync? Try it out. If your database cannot catch up in time, then you know this option won't work for you. And with AWS pay-per-use policy, your risk is minimal, since you are only paying for the resources you consume for the time you consume them. Again, for large databases, initial synchronization could be achieved using database backup delivered by using a Snow device. In most scenarios, your always-on availability group would rely on Active Directory to support Windows failover cluster. So if you extend your availability group to AWS, you will have to extend your Active Directory to AWS as well. However, your security policies may preclude extending Active Directory to the cloud, or you may not want to carry your current AD design to AWS and prefer to start anew. To address this issue, you may use Distributed Availability Group feature of SQL Server. The cluster on AWS will rely on its own Active Directory. On AWS, you may deploy self-managed Active Directory on EC2, or you may take advantage of AWS Managed Active Directory to simplify directory support and maintenance. To create Distributed Availability Group, you would have to establish AD Trust or enable certificate-based mutual authentication between the on-premises and in the cloud always-on availability group clusters. Only primary node of Distributed Availability Group, which is called forwarder, receives update from the availability group on premises. This feature cuts down on the amount of replication traffic that traverse VPN or Direct Connect link. What if you would like to avoid complexities of setting up replication or dealing with extending availability groups? For this case, AWS offers AWS Data Migration Service, or AWS DMS. DMS is highly resilient and self-healing. It continually monitors source and target databases, network connectivity, and the replication instance. In case of interruption, it automatically restarts the process and continues the migration from where it was halted. Let's see how this service works. AWS DMS migration starts with setting up DMS replication instance inside your AWS VPC. You select the size of DMS replication instance based upon the size of your database. AWS DMS migration includes several phases. The first phase, initial data load, starts with DMS creating schema objects if they do not already exist in the target database. AWS DMS creates only those objects that are required to efficiently migrate the data. These include tables, primary keys, and in some cases, unique indexes. It does not include secondary indexes, foreign key constraints, defaults, and so on. Our best practice is to generate and manually apply the data definition language for the target database to ensure that all the definitions transfer. This way, you know nothing is missing. If the target schema was created manually, it is recommended that for initial data load, you disable foreign keys and auto-increment constraints. As soon as the full load starts for a particular table, AWS DMS starts to cache changes applied to this table. When the full load for a given table is complete, the AWS DMS immediately begins to apply cached changes for that table. Initial data load can be paused. When restarted, it will continue from where it was stopped. However, tables which were in progress of loading when paused will be reloaded. AWS DMS integrates with AWS Snow family of products. So for large databases, initial data load can be performed offline. After AWS DMS applies all cache changes at the end of initial data load, tables are transactionally consistent. At this point, AWS moves to the ongoing replication phase, applying changes as transactions. For tables with primary keys, AWS DMS uses SQL Server replication to capture changes. Changes to tables without primary keys are captured using SQL Server Change Data Capture feature. At the start of the ongoing replication phase, a backlog of transactions generally causes some lag between the source and target databases. The migration eventually reaches a steady state after working through this backlog. Let's explore how is it that DMS can enable near zero downtime migration. The customer starts by launching a DMS instance in their AWS account. Then the customer provides database connection information to connect to both their on-premises and AWS database instances. Next, the customer will select which tables, schema, or databases they want to migrate, and DMS will load the data and keep it in sync on an ongoing basis. Finally, when you are ready to cut over, you simply change the application configuration to point to the new AWS database instead of the existing on-premises database. We had quite a thorough review of Rehost and replatform migrations of SQL Server workloads to AWS. What else can we do? The last R of migration, refactor for AWS. Refactoring is the most advanced method of migrating SQL Server to AWS. It is more complex than other migration approaches because it not only changes your database platform, but also can affect the processing logic, application code, and overall structure of your application. To perform a successful refactoring migration, you generally need more database, application, and cloud skills than any other migration method. Understanding this complexity, we offer Amazon Database Migration Accelerator, a solution that brings together AWS migration tools and AWS database expert to help customers migrate away from traditional commercial databases at fixed prices. Cloud-native AWS managed database services merge the flexibility and low cost of open-source databases with the robust enterprise feature sets of commercial databases. Refactoring your databases to cloud-native solutions frees you from the lock-in into old guard, monolithic, proprietary, and expensive vendor offerings, which often come with punitive licensing terms. Refactoring is also the most rewarding method for long-term business outcomes, as it truly accelerates your pace of cloud innovation that continuously reduces cost while increasing performance, resilience, and responsiveness. It will also get you well positioned to move to new services such as purpose-built database offerings and serverless database solutions. We already introduced AWS DMS as SQL Server migration tool. However, AWS DMS also allows to target open-source databases like MySQL, PostgreSQL, MariaDB in Amazon RDS family, as well as cloud-native relational database Amazon Aurora and data warehouse Amazon Redshift. However, besides just moving data, refactoring your database to one of these offerings will also require some changes to database schema and associated application code. And that's where the AWS Schema Conversion Tool, or SCT, shines. It provides a project-based user interface to automatically convert the database schema of your source database into a format compatible with selected target platform. If schema from your source database can't be converted automatically, AWS SCT provides guidance on how you can create equivalent schema for your target platform. AWS SCT can also review your application code in an attempt to identify and modify your code to achieve compatibility with the target database platform. AWS SCT integrates with AWS DMS to implement schema conversion during database migration. One of the most popular targets for refactoring SQL Server for AWS is Amazon Aurora for PostgreSQL. Typically, refactoring for Aurora PostgreSQL required refactoring of the database as well as reworking the application for compatibility with PostgreSQL driver and native PostgreSQL dialect, PL/PGSQL. Not anymore. Understanding popularity of Amazon Aurora PostgreSQL, AWS developed and made available, currently in preview, a new translation layer that enables Aurora PostgreSQL to understand commands from applications written for Microsoft SQL Server. With Babelfish, Aurora PostgreSQL now understands TSQL, Microsoft SQL Server proprietary SQL dialect, and supports the same communication protocol. So your apps that were originally written for SQL Server can now work with Aurora with minimal code changes. As a result, the effort required to modify and move to Aurora applications developed for SQL Server 2019 or older is reduced, leading to faster, lower risk, and more cost-effective refactoring. Babelfish is a built-in capability of Amazon Aurora and does not have additional cost. After signing for the preview, you can enable Babelfish on your Amazon Aurora cluster with just a few clicks in the RDS Management Console. Let's review what we learned during our session. To achieve successful database migration to AWS, you have to perform several steps, starting with identifying your SQL Server version and edition to decide on your target platform. Review your authentication requirements, which may lead to Active Directory concerns. Consider amount of data to be migrated and throughput of your link to AWS. Select your migration strategy and appropriate migration method. Consider using help with your migration effort. Apply AWS well-architected framework to your target cloud environment and definitely perform evaluation and optimization of your platform after migration. We listen to you, our customer, to know what topics matter to you. If you like this session, please rate this session as 5, so we know that you like the content, and we will make sure to include more of these topics in the future. When you rate this session, please also share your comments about what you liked and didn't like, so we can continue to improve our presentations based upon your feedback. Thank you.